Hello again, and welcome to Physics Made Simple by Dr. Eat. Today's topic is going to be drawing and analyzing qualitative motion maps for constant speeds. So, when illustrating a motion map, we see that we have dots and arrows. The dots are usually a representation of uh, the actual object position on a motion map, and they also identify how many seconds we have on this motion map. So you're going to see 6 dots if it's 6 seconds, and so forth and so on. The arrow not only represents the direction of motion of the object, it also represents the magnitude, and we will see that in the next video when we talk about accelerating objects. In this video, it's only a constant positive velocity that we will look at. Also, one of the things you need to pay attention to is when you have those dots on top of each other, like you can see over here, um, these are stationary. This object is a stationary object, and therefore we know that this object is not moving for however long. So if we have 2 dots, that's 2 seconds. 3 dots, that's 3 seconds. So looking up here, we can see that we have 1, 2, 3, 4, 5 seconds within this period, and the direction is to the right. The magnitude of the motion right here, you can actually see 1, 2, 3, 4. Okay, so from dot to dot is actually 4 meters, and we have 6 seconds. So we can say this is 4 meters for every second. Right here, it is 0 because in 2 seconds this object did not move, and so forth and so on. So when we talk about constant positive velocity, we are expecting the motion of this object to be positive, and we're also expecting the size or the magnitude of motion to be constant. What does that mean? That means the distance between the dots that we have over here is going to be the same all throughout. So from here, from dot to dot is going to be the same distance, and it is going in a positive direction, which means it's going forward. On a graph, 2 things we need to notice. One of them is the fact that these are up in the positive quadrant, and the fact that there is no acceleration, which means as the time passes, the velocity on a velocity time graph remains the same. On a position time graph, we see that as the time passes, the position is changing, and on a velocity time graph, the velocity is remaining the same. So constant positive velocity have the same magnitude in the positive direction, positive quadrant of the graph. Okay, so let's begin by plotting information using a table. First thing we notice that this is a position time graph. So we'll go ahead and write down that this is a position, which is x, and this is the time per second. And we begin at 0, and we finish at after 5 seconds. And this information is being plotted from here. So we'll go ahead and put 1 second, 2 seconds, 3 seconds, 4, and 5 seconds. During those 5 seconds, we can go ahead and right click. In the first second we move 10, in the second we move 20, and then 30, 40, and then 50. Then go ahead and connect those from 0, and we can um, begin working on the actual filling of the table. Okay, so to put those on the table, our starting point at 0 seconds, it was 0 meters. So 0 meters. And then our stop, we stopped at 50 meters. Our direction, we notice that we are in the positive quadrant, so that's to the right. Let's write that down. Our displacement, it's a position time graph, so my displacement is going to be final position minus initial position. So final position is 50 minus 0 is equal to 50 meters. And that's my displacement. And the distance, total distance, we know is 50 meters. Velocity is going to be displacement over time, which is 50 divided by 5. So this is my 5 seconds. 50 divided by 5 is equal to 10 meters second. So that's 10 meters per second to the right because it's a velocity, and for the speed is only 10 meters per second. The total time was 5 seconds. So what we expect to see on our motion map is that we have at least 5 dots for the 5 seconds, and they are moving to the right. I'm going to go ahead and put those. 1, 2, 3, 4, 5. And since we know that these are moving to the right, and there's a total of 50, we know the size of each one is going to be 10 meters. So we can go ahead and write that between this point and this point should be 10. So that's 10, 20, 30, 40, and then 50. That's 0, 10, 20, 30, 40, and okay. So that's 10. In the first second between 0 and 1, we went from 0 to 10. And then in the second second between 1 and 2 seconds, we went from 10 to 20, 20 to 30, 30 to 40, 40 to 50. And this is how we fill out our motion map. We have 5 total seconds. We went from 0 to 50. And the size of each one of these is our velocity. This is our positive constant velocity. Let's go ahead and go on to extracting information from an actual graph. So in this one, we can actually see that we have information on a graph, and we need to extract that information, place it both on a table as well as a motion map. Let's begin by identifying our starting point, ending point, placing them here. So we started at 8 meters and we stopped at 20 meters. And the direction, again, it's positive to the right. The displacement, final position minus initial position. So final position, displacement is equal to final, which is 20 minus initial 8 is equal to 12 meters. So displacement is 12 meters. The distance covered is going to be 12 meters. And we know that our velocity is going to be my displacement over time My displacement is 12. My time is a total of, notice, 6 seconds. So 12 over 6 is 2 meters per second. So my velocity is 2 meters per second to the right. My speed is 2 meters per second. My total time is 6 seconds. Okay, let's go ahead and place those on a motion map. Even though we have a graph that starts at 0, our line or our beginning or starting point is at 8. So right here, we need to show that we know that this is going from 8. So I'm going to go ahead and put identify the points as into increments. We can do that. So 0, 2, 4, 6, 8, 10, 12, 14, 16. We know we have a total of 6 seconds. We know my starting point is at 8. Go ahead and first put our dots or the seconds. So my first one is over here at 8. My second one, 2 meters size, 10, 12, 14, 16, 18. How many we said? We said 6. So this is our last one. Let's go ahead and the size of our arrows is going to be 2, 2, 3, 4, 5, and 6. So again, my starting point is 8. My ending point is 20. The time is 6 seconds. That's 1, 2, 3, 4, 5, 6. The size of these is 2 meters every second, which is all right. This is for working on this backwards. Let's go ahead and see what else we may be able to extract if the question is given in a different way. Let's look at this. This is actually a fun way because we are doing this completely backwards. We actually have the motion map and we need to put it both on a table and a graph. The first thing I see is, or the first thing that I would do is go ahead and identify how many seconds do I have. So let's go ahead and count them. I have 1 second, 2 seconds, 3, 4, 5 seconds, and we have a velocity, which is the size or the distance between these 2 seconds. That's going to be the size of my velocity. And we have an initial point or initial starting point at 0 and an ending point at 30. Okay, so let's go ahead and write these down. My starting point was at 0 meters. My stop was at 30 meters. My direction is to the right. My displacement is final. Displacement is equal to final minus initial is equal to 30 meters. And it covered 30 meters. The velocity is actually the size between each second, which is, if we look over here, the size between this point and this point is how many? 6 meters per second to the right. 6 meters per second to the right. Speed is the same without, it's a magnitude only without direction. And the total time we counted was 1, 2, 3, 4, 5 seconds. Okay, so let's go ahead and draw this on the position time graph. Notice this is a position time graph. So x, t in seconds, my x is in meters. Okay, so how many seconds? We have 5 seconds. Let's go ahead and identify those. This is, let's go ahead and use green. So 1 second, 2, 3, 4, 5 seconds. And we have a, um, a position between 0 and 30. So we're going to move by fives, or actually we can move by threes. Let me see if we can move by 3, 6. Okay, that will be perfect. So this is my 3, 6. Let's do this the other way around. Let's go ahead and move by 6 because I don't have enough space. Okay. Recount. All right. 6, 12. Okay. So at the first second, we moved 6. Go ahead and do that. At the second, which is right here between 6 and 12, 12 and 18. In the third second, we move to 18. In the fourth one, we move from 18 to 24. And then from 24 to 30. Okay, so we can go ahead and connect those. And we can basically conclude with this information because knowing that uh, we have a starting point that matches, an ending point that matches, a distance between each second that matches, which is 6 meters every second, we are basically done completing this one. Let's see what else we can have, or how else we can see a question that has to do with uh, constant positive velocity motion maps. This is another example that we have, but in this situation we have an object that is actually traveling to the left or backwards. It starts off with a position of 27, ends up at position 3 meters in a total time of 8 seconds. So my starting point is 27 meters. My ending point is 3 meters. The direction is going to the left or backwards. My displacement is equal to the final position, which is 3, minus initial position, which is 27. That is equal to minus 24 meters to the left. So we are going in the negative direction or backwards, minus 24 meters. The distance covered is actually 24 meters. The total velocity is equal to your displacement, which is minus 24, over your total time, which is 8 seconds, which is equal to minus 3 meters per second. So we are going 3 meters per second backwards. So we can write that minus 3 meters per second. So to the left. All right, my speed is going to be 3 meters per second, and the total time is 8 seconds. Okay, so my increments over here are going to be, the easiest way to do this is in threes, because that's the size of my velocity, and it's much easier to do it that way. Let's go ahead and change color, and we are going to go 0, 3, 6, 9, so we can go ahead and plot our points, which identify our seconds. We're going to say we started off at 27, okay? And we went backwards every 3 seconds. So we can go ahead and put our second. Where did we end up? We ended up at 3. So this will be our last one. Let's go ahead and the direction is backwards. So our arrows are going backwards. The size of our arrows is 3 meters. Okay. And let's review. My starting point is 27. My ending point is 3. The total seconds are 8. So let's go ahead and count those. Let's change the color. 1, 2, 3, 4, 5, 6, 7, 8 seconds. The size of those are the velocity, 3 meters. And we are going to the left. And that's basically all the examples I can remember of giving my students with constant positive velocity. Let's go ahead and review. One more, but this one is going to be a motion map that is actually going backwards. We're going to quickly do this one. It's also another easy one. This is a position time graph, and it starts at 10. It ends at 0. So we are going backwards, and we have a total of 1, 2, 3, 4, 5 seconds. So right away we can go ahead and write our 5 seconds. Also write our starting point to be 10 meters. Our ending point is 0 meters. Our direction is backwards or to the left. Our displacement, which is final, minus initial, which is negative 10 meters, minus 10 meters. So the total distance is actually 10 meters. The velocity is equal to the total distance or displacement divided by the total time, which we said it was 5, and that is equal to minus 2 meters every second. So minus 2 meters every second. The speed is 2 meters every second, and we know that this is going to the left. Awesome. Let's go ahead and do our position time. This is my position. This is my time. I have a total of 5 seconds. I am going to use these 1, 2, 3, 4, 5 seconds. And I am going to plot my points. My first point went from 10 to 8. So we started off at 10. So if I was to use these in 2, 2, 4, 6, 8, 10. So at time 0, we were here. At 10, at time 1, so in 1 second, or in the first second over here, we went from 10 to 8. So in the first second, we were here. Okay. In the second, we went from 8 to 6. So from 8 to 6. The third second, we went from 6 to 4. And then fourth second, we went from 4 to 2. And then in the last second, we went back to 0. Connecting these, this is what this would look like. Again, this is pretty much straightforward. Now that we've practiced enough, we look back at the information. We started off over here at point 10. We ended up over here at point 0. The total time is 5 seconds. And the distance between each one of these is the size of our velocity. And we know we are going backwards. So minus 2 meters every second. So these are the final tips and takeaways. I recommend that you pause and take a look at them, probably screenshot them. That way you'll remember what exactly you need to know in order for you to complete any question that has to do with constant positive velocity. Thank you for following my channel. Please come back and watch our next video, which is going to complete or go over how to analyze a graph that is accelerating or extract information about accelerating objects. Thanks again.